Hello, this is question 1 from the Cambridge International Education winter exams from 2020. It is from paper 2-2. As well as being on the screen right now, you can also find a link to an image of this question in the description below. I recommend that you pause the video now and try the question first before you see my solution. As you can see, the question involves a fourth order polynomial and a second order polynomial that they are going to ask you to divide into the first. I've drawn the two polynomials here on the board. First we have fx is equal to x to the power of 4 minus 3x to the power of 3 plus 5x to the power of 2 minus 6x plus 11. That's the fourth order polynomial because it's power of 4. And they gave us this polynomial, that's a much smaller one, x squared plus 2, a second order polynomial because it's the power of 2. Now they ask us to divide one into the other. I'm going to write that like this. X squared plus 2 divided into, and I'll just jot this one down. And after we divide this in, what they've actually asked us to find is the quotient and the remainder. So that'll be the first part of this question, understanding what those two words mean. The quotient and the remainder. To do that, I'll just give a slight little example here. If I divided 2 into 9, how many times does 2 go into 9? It goes in 4 times with a 1 remainder. So this, we probably would have done maths like this when we were younger in a primary education. We can do dividing just the same with these much more complicated terms. So this is the quotient and this is the remainder. That's what I'd like to find here. So we need to find how many times this goes into this and with what remainder. First thing I need to do is actually change this a little. Oh no, this one's fine. 4, 3, 2, 1, 0. That works fine. This one here is a little harder. I like to change it this way. What was the number? 2. Okay, I like to change it this way because it'll just make things a lot neater as we go on. To have an x squared, an x to the power 1, and an x to the power 0. So that's the one little change I'm going to make at the start. Other than that, here's what I'm going to do. I'm going to look at the first term of this and the first term of that. See, what do I need to multiply this? What do I need to multiply this by to make this? Or another way to say it is, what do I need to divide this by? Or what happens when I divide this by this? What do I get? Either way I phrase it, I get x squared. So x squared times x squared makes x to the power of 4. Now I'm going to do this all the way along here and get the quotient. This is how I'm going to divide it in. This is the algorithm we're going to use to divide a polynomial into a polynomial. So x squared multiplied by this x squared, we'll write it down here, x to the power of 4. Because it's not only this it multiplies, it also multiplies by both of these guys. X squared by 0 is 0, so we'll write that one in plus 0. I don't really need to put in the x squared by x1 is x to the power of 3, but really it's still 0. You don't need to put that part in. It's okay if you do though. X squared times 2 is 2 to x squared. And yeah, we're going to see how close we got here. We're going to take this away from this number and see how close we got to the right one. I'd also like to find out, you didn't have to put these numbers in. Once you made sure to skip this guy here in the middle. Anyway, let's see how close we got. We'll take them away. This minus this is 0, nothing. Minus 3x to the power of 3 minus 0 is still minus 3x to the power of 3. 5x squared minus, let's put in a little minus there. 5x squared minus 2x squared is 3x squared. And let's take down the next term just to make sure we have 3 to act on these 3. And we start again. We just see what number do I need to multiply this by to get this. So this time it's going to be a minus 3x. Let's double check that. Minus 3x times x squared comes out as minus 3x times 2 more x's, 3 x's. Yeah, that's the same number. Okay, that's how many times this number divides into this one. But let's stay going. Let's multiply this into all 3 of these. We'll get 0 minus 3 times 2 is minus 6. Minus 6x. There we go. We take these away. That'll change to a plus and it'll disappear. This number minus this number is 3x squared. minus 6, this will change to a plus. That disappears as well. And we're left with a 0 there. Let's go plus 0. And let's take down the last term, 11. And let's do it one more time. Remember, this is going to be the quotient up here we find. Okay, so what number do I need to multiply x squared by to get 3x squared? Well, it's just 3 in this case. You can see a pattern there. X squared, x1, x0. And that pattern would stay going if you had bigger numbers than this. Okay, so 3 times x squared is 3x squared. 3 times 0 is 0. And 3 times 2 is 6. Take these away. That's gone. Take those away. It was already gone. 0 minus 0 is still 0. 11 minus 6 is 5. There we go. There's our answer. They asked for the quotient. Q is equal to x squared minus 3x plus 3. This number here. And they asked for the remainder. The remainder is equal 5. So a way you could just say this out loud would be the function fx, when divided by x squared plus 2, gives a quotient of x squared minus 3x plus 3 with a remainder of 5. That's how you'd say it. So just like before, 2 divides into 9 with a quotient of 4 and a remainder of 1. It just doesn't come up that often that we use these quotient or remainder words. Okay, if you have any questions about that, leave them in the comments below and I'll do my best to get back to you. Thanks for watching and have a good day.